Welcome back to Afriplex Blockchain Lab course. Today we continue about position of brain in AI learning. Introduction. The human brain is the ultimate inspiration for artificial intelligence, AI. Many AI systems are designed to replicate how our brains process information, learn, and make decisions. This lesson explores the parallels between the brain and AI, focusing on how AI mimics neural networks and the learning process. Understanding these similarities helps students appreciate AI's capabilities and limitations. The brain versus AI. The human brain. The brain is a highly complex organ, consisting of approximately 86 billion neurons. These neurons communicate through electrical and chemical signals, forming intricate networks that enable us to think, learn, and adapt. Key characteristics of the brain include neuroplasticity, the ability to adapt and rewire itself based on experiences. Parallel processing, handling multiple tasks at the same time. Learning through experience, developing knowledge and skills by recognizing patterns and drawing conclusions. AI's neural networks. AI systems, particularly deep learning, are inspired by the structure and function of the human brain. Artificial neural networks, ANNs, are designed to simulate the way neurons in the brain work. Key characteristics of neural networks include nodes as artificial neurons. Each node in a neural network functions like a neuron, processing and transmitting information. Connections and weights. Like synapses in the brain, these determine the strength of the connection between nodes. Learning through data. Neural networks learn by adjusting weights based on the input and desired output. Example: facial recognition software uses neural networks to identify patterns in images, mimicking how the brain recognizes familiar faces. How AI mimics brain function. 1. Learning and pattern recognition. The brain learns by identifying patterns in sensory inputs. Similarly, AI systems like machine learning recognize patterns in data to make predictions or decisions. Example: the brain recognizes a cat by analyzing its features, e.g., whiskers, ears. AI achieves the same by analyzing pixel patterns in images. 2. Decision-making. The brain uses past experiences to make decisions, often weighing pros and cons. AI algorithms, such as decision trees, use similar logic to evaluate outcomes. Example: AI in self-driving cars analyzes road conditions and decides whether to stop, turn, or accelerate, just as a driver's brain processes similar inputs. 3. Error correction and adaptation. When we make mistakes, our brain learns from them to improve future performance. AI systems, particularly through supervised learning, also adjust based on feedback to minimize errors. Example: AI in language translation improves accuracy by analyzing user feedback and correcting errors. Applications of brain-inspired AI. 1. Healthcare. AI mimics brain processes to diagnose diseases and recommend treatments. Example: IBM Watson analyzes medical data to suggest personalized treatments, similar to how a doctor uses knowledge and experience. 2. Robotics. Robots with AI simulate human brain functions to perform complex tasks like walking, grasping objects, and even social interactions. Example: humanoid robots like Sophia process visual and auditory data to respond to human cues. 3. Education. Brain-inspired AI helps create adaptive learning platforms that personalize content for students based on their strengths and weaknesses. Example: AI in Duolingo adjusts language lessons to match a learner's progress, similar to how a teacher tailors instruction. Brain-inspired learning models in AI. 1. Supervised learning. Inspired by the way the brain learns from labeled experiences, e.g., this is a cat. AI example: training a neural network to recognize images of cats by providing labeled data. 2. Unsupervised learning. The limitations of AI compared to the brain. While AI mimics certain brain functions, it has significant limitations. 1. Lack of common sense. The brain integrates vast amounts of context and experience, while AI struggles with basic reasoning outside its training data. Example: A human understands that the sky is blue is unrelated to blue is a color of sadness, but AI might confuse these. 2. Emotional intelligence. Conclusion. The human brain has inspired some of the most advanced AI systems in use today. By understanding how the brain and AI are interconnected, students can better grasp the potential and limitations of AI. As AI continues to evolve, its ability to replicate brain functions will bring transformative changes to industries and everyday life. In the next lesson, we'll explore how AI can enhance students' research capabilities. Let's dive deeper into practical applications.